Hi, my name is Mr. Chu and I welcome you to my study room. If today is your first time joining me, then I strongly encourage you to subscribe to this channel for more videos. Starting from today, our study is going to be centered around coordinate geometry. And in today's lesson, we are going to learn about what coordinate geometry is, after which we will calculate for the distance between 2 points. And the lesson will end with the applications of the distance formula, for which we'll be able to use the coordinates of the vertices of a triangle to determine what type of triangle it is. Join me as we go into the lesson. Thank you. Let's try to define what coordinate geometry is. Coordinate geometry is the study of the geometric properties of points, straight lines, and curves using algebraic methods. That means that when we are working around points, lines, and curves, instead of using instruments to measure, we are going to use points or coordinates for our calculation. We'll start with how to find the distance between 2 points. That is the length of a straight line. And we just have the definition of straight line there. A straight line is formed when 2 points are joined by a straight edge. Taking two arbitrary points A and B, with A having coordinates x1 and y1 and B having coordinate x2 and y2, we can represent that on the Cartesian plane. So let me draw my Cartesian plane quickly. So here I have my y-axis and my x-axis too here, and then let me choose the two arbitrary points A and B in one of the quadrants. Alright, this is my A and this is my B. Let me join the two with straight line. Alright, so that forms line AB. To measure the length of line AB without the use of ruler, I'll have to trace the point A and B to form a right angle triangle. After which I will use the idea of Pythagoras theorem to calculate for the length of AB. So I'm using straight line to trace the points A and B to meet at a right angle, and there is my right angle. Now I will trace the point A to the x-axis and call it x1, and y to the y-axis and call it y1. Alright, then we do the same thing to B. We trace x to the x-axis and call it x1, x2. We trace x to the x-axis and call it x2, and y to the y-axis and call it y2. The base here, let's call the base of our triangle x, probably because it's along the x-axis, and the height y because it's along the y-axis, and call the line AB H, probably because that is the hypotenuse of the triangle. And then by Pythagoras theorem, whenever you take any right angled triangle, the square of the hypotenuse should be equal to the sum of squares of the other two sides. That is, h squared will be equal to x squared plus y squared. But the length x here is the measurement in relation to 0. Let me put my 0 there in the origin. Is the measurement from 0 to x2 minus the measurement from 0 to x1. That is what will give us our x. So that will give us x2 minus x1 for our x, and the whole thing is squared. So x2 minus x1 squared, yeah, plus same thing is going to happen along the y-axis. That is the measurement from 0 to y2 minus from 0 to y1. So that's y2 minus y1 all squared. A squared is also the same as our line AB. So let me write it as magnitude AB squared be equal to what we have. All right, let's continue to work it further. We are looking for AB, the length AB, and not the length AB squared. So you know that will means we have to take the square root of both sides. Taking the square root of both sides, we are going to have the length AB be equal to the square root of x2 minus x1 all squared, that is the change in x squared, plus change in y squared, which is the same as y2 minus y1 all squared. And this gives us the length, the formula for calculating the length of the line joining 2 points, or the distance between 2 points, when the coordinates of the 2 points are given as x2 and x1, where x1 and y1 and then x2 and y2 stands for the x and y coordinates of the first and second point respectively. Let's take an example to explain this formula. Example 1 says find the distance between A 6 negative 4 and B 0 4. So we go back to our graph and represent these 2 points A and B on our graph. So here we have the point A, -6 4, and our point B 0 4, in our Cartesian plane. Alright, then we join the two of them with a straight line to get line AB. What I'm going to do is to use a ruler to measure the line AB and see the length. And according to our ruler, that gives us 10 centimeters. Now we are going to use, this is the normal measuring, the geometric measurement. But since this is about using algebraic solutions, we are now going to use the 2 points by tracing it just like the way we explained from the beginning to check whether we are still going to have 10 units. So let me use my ruler to trace my points to form a right angle triangle. So we trace A to the top. There you have it. And then we trace to meet the B at right angle. And there you have that one too. Alright. So here we have our square corner. Alright. And let's still call the movement along the x-axis x and the movement along the y-axis y, and the length of our line AB, the ABH. So we are now going to fix these 2 points into the formula and see whether that will be what we are getting. We will get 10 units or not. Alright. So we have to start by quoting our formula that the length or magnitude of the line AB is equal to the square root of change in x, which is the same as x2 minus x1 all squared, plus change in y, which is the same as y2 minus y1 all squared. and now we fix our numbers into it. So our x2 is the x coordinate of the second point, which is 0, and then our x1 is 6, the x coordinate of the first point, which is 6, and our y2 is y coordinate of the second point, which is 4, minus our y1, which is y coordinate of the first point, which is -4, then all squared. 0 minus 6 is -6, so -6 squared plus 4 minus -4 is 8, so a squared. When we add the two of them together, we are still going to have square root of -6 squared is 36 plus a squared is 64, and that will give us square root of 100, and square root of 100 is 10. Therefore, the length AB equals 10 units, which is the same as what we got here on the graph when we use the ruler to measure. So this is a proof to us that we can use the point to measure the length of a line for if we know the coordinates of the ends of the line without necessarily sketching the line. So that is the aim of this lesson. In the next example, we are no more going to use ruler. We are not going to represent on the Cartesian plane. We are just going to use the point, since we've used the first example to explain that it means the same thing when we represent the point. So let's go and take the second example now. For example 2, we are finding the distance between the point M with coordinate 2, 5 and N with coordinate -3 and 3. Some people mix the x1 and the y1, x2 and y2 when they are fixing it into the formula. So it will be advisable to write the x1, y1 and x2, y2 at the top, and that is what I'm doing before we'll just look at it and fix it into the formula. So you can see that from what we have at the top there, our x2 is -3 minus our x1, which is 2, all squared. Then our y2 is 3 minus y1, which is 5, all squared. That is going to give us -3 minus 2 is -5 all squared, plus 3 minus 5 is -2 squared. -5 squared will give us 25, plus -2 squared will give us 4. And this will give us square root of 29, because 25 plus 4 is 29. And in decimal, this will give us 5.39. And that is 5.39 units. The length of the line connecting the point M and N with the coordinate above, or the distance between the point M and N. It means that if you use graph book right now to plot these 2 points on the axis and you measure with a ruler, you are going to get 5.39 units. I will give you the next examples for you to try on your own. So pause this video and write questions 3, 4, and 5 and find the distance between each pair of points. And feel free to share your answers with me in the comment box. This is not the only thing we can use this formula or this idea for. This idea of calculating the distance between points can be applied to other questions. So that brings us to application to triangles. So we can apply this thing we just did now, the distance formula, to find the length or size of a triangle if we know the coordinate of the vertices of the triangle. So that is an application we are going to do now, determining the type of triangle using the distance formula. And by determining the types of triangle, you know triangles can be classified according to the length of size of the triangle. So when we are given triangle, let's say triangle ABC, just as I have it on the board right now. Let me label it quickly. Yeah, so we have our A here, our B here, and our C here, with respective coordinates x1, y1 for A, x2, y2 for B, and x3, y3 for C. Then it will be expected of us to calculate the distance AB, which is the same as the length or magnitude of the side AB. Then we find the magnitude of the side BC and magnitude of the side AC using the distance formula. And this will be the conclusions that will come if all sides are equal, meaning that if the length or magnitude AB equals magnitude BC equals magnitude AC, or in other words, if all three sides are equal, then we can conclude that our triangle is an equilateral triangle, because equilateral triangle has all three sides equal. Then let's go to the second understanding we can get from here. If two of the sides are equal, or the length of two of the sides are equal, then we conclude that the triangle is an isosceles triangle, because isosceles triangle have two sides equal. Then let's take the next understanding. If after calculation all three sides are different or unequal, then we'll conclude that that triangle is a scalene triangle, because a scalene triangle is a triangle with all three sides unequal. That is not the only thing we can pick from this formula or from this calculation. Also, if after calculation the length of our three sides form a Pythagorean triple, then we can conclude that our triangle is a right-angled triangle. When you square the longest side, it will be equal to the sum of squares. That means you square each of the other two sides and add them, and it's equal to the square of the longest side. Then we conclude that that triangle is a right angle triangle. Let's go take some examples just to make this point a bit clearer. So let's work out some examples. Example 1 says, determine the type of triangle whose vertices are A 1 1, B 3 2, and C 2 negative 1. So like we said earlier in our previous slide, that with this, when the question asks us to determine the type of triangle, you just have to find the length AB, the length BC, and the length AC. Then we compare. So finding the length AB, our x1 is 1, y1 is 1, x2 is 3, and y2 is 2. And I advise you that you can write them at the top there so that you don't get confused. So let's fix that into our formula. So our x2 is 3 minus x1 is 1 all squared plus our x2, our y2 is 2, and our y1 is 1 all squared. 3 minus 1 is 2, then we square it, plus 2 minus 1 is 1, then we square it. 2 squared is 4 plus 1 squared is 1, so that will give us square root of 5 units as the length of our side AB. Then we go calculate our side BC. So because B is our first point, 3 becomes our x1 and 2 our y1. And for C, which is our second point, 2 our x2 and -1 our y2. Let's now fix that into the formula. So we are going to have 2 minus 3 all squared plus 2 minus -1 all squared. 2 minus 3 will give us -1 squared, then plus 2 minus -1 will give us 3, then squared. -1 squared will give us 1, then 3 squared will give us 9. When we put it all together to give us square root of 10 units. That is the length or magnitude of BC. Now we go to the length AC. Again, our x1, y1, and x2, y2 will change because our first point is now A and our second point C. So going back to the point, you see that now our x1 is 1, our y1 is 1, our x2 is 2, and our y2 is -1. So going back into the formula, we are going to get 2 minus 1 all squared plus -1 minus 1 all squared. And 2 minus 1 will give us 1, so squared plus -1 minus 1 is -2 squared. And 1 squared is 1, and -2 squared is 4. Adding the 2 give us square root of 5 units. Alright, so now that we have found the 3 sides of our triangle, we go back and check the length, and from here we can see that the length AB here, which is square root of 5 units, is equal to the length AC, which is square root of 5 units also. This means that our triangle has 2 sides equal, and we can conclude that therefore triangle ABC is an isosceles triangle because it has 2 sides equal. We take another example. Example 2 says, what type of triangle is EFG with vertices E -2 and 2, F 3 and 2, and G -4 and 5? Here, I will leave this one for you to solve on your own, so you can pause the video and solve, and when you finish, you compare with the answer I am going to write now. after solving, you must get a scaling triangle because none of the three sides will be equal. All right. I give you a few more questions for you to try on your own. So you can pause the video and copy each of them one by one, and feel free to share your answers with me in the comment box. Alright, so question 3 says the triangle PQR has vertices at P negative 3, 4, Q 3, 4, and R 0, 9. Show that triangle PQR is an equilateral triangle. So that means you have to work it all out, and after working, if you fix the coordinate into the formula as well, you find PQ, you find QR, and you find PR. The length of all three sides should be equal. If that happens, then you can conclude that triangle PQR is an equilateral triangle. So immediately you finish solving and they are equal, you conclude that therefore triangle PQR is an equilateral triangle. Thank you.
Welcome back, and this is where we end today's lesson. I hope it's been of help to you. If yes, then why not consider subscribing to this channel so that anytime I upload a video, you'll be notified directly. Don't forget to like, comment, and share with friends so that they can also take part. Until we meet again in the next lesson, it's bye for now. Thank you.